Today, we will learn grouped frequency distribution. Your school must have a fitness test every year. A fitness test was also taken at Adarsh Public School, in which the pulse rate of 100 children was thus obtained. The numbers collected for any information is called data. But it is not easy to get information from this data easily or draw any conclusions. Such data is called as raw data. To understand them, we can arrange them in ascending order or descending order. Pause the video and arrange them in ascending order. Is it easy? As the number of figures increases, it becomes difficult to organize them in any order. Another way of arranging these is that we create a table and write the pulse rate in first column and show how many times the pulse rate is repeated in the second column as tally marks and write the number of the tally marks in the third column. This number will tell us how many times the pulse rate is repeated in the data. The number of times an observation is repeated is called the frequency of that observation. For example, the pulse rate of 3 children is 61. We say that the frequency of 61 is 3. By arranging the data in such a way, we get the frequency distribution table. Since data groups are not created here, this is an ungrouped frequency distribution table. Since the data here are many and varied, the frequency distribution table will be longer. It will also be difficult to make such a table and get any information from it. In such a situation, we can make them smaller by forming groups of data. The smallest number in the given data is 61 and the largest number is 99. In this way, the range of data is from 61 to 99. So we will condense the data into groups in such a way that the numbers greater than or equal to 61 and less than or equal to 99 are included in them. Here we can make groups like 61 to 65, 66 to 70, 71 to 75, etc. We call each such group a class or class interval. The smallest number in a class interval is called the lower class limit of that class interval, and the largest number is called the upper class limit of that class interval. The difference between the upper class limit and lower class limit of a class is called class size or class width. Keep in mind that the size of each class interval is the same here. Now we will represent the data falling in these groups by tally marks. The first number is 74, which will be included in the class interval 71 to 75. The second number is 61, which will be included in the class interval 61 to 65. Similarly, we will represent all numbers as tally marks. By counting the tally marks, we will know how much data is included in each class interval. That means, what is the frequency of each class interval? This type of table in which the data is grouped or organized by grouping is called a grouped frequency distribution table. Now, we can get information from this table more easily, like the pulse rate of 25 children is between 71 to 75. We can also form groups of 60 to 65, 65 to 70, 70 to 75, etc. To organize the given data, let's organize the data into these groups. The first number is 74, which we will include in the class interval of 70 to 75. The second number is 61, which we will include in the class interval of 60 to 65. The third number is 65. Can you tell in which group we will include it? Think. Here we see that the number 65 can be included in these two groups, 60 to 65 and 65 to 70. But if it is included in both, then it will be counted twice, which is wrong. To avoid this, we follow convention. The common or overlapping observation between two intervals is considered in the higher class interval. In this way, we will include 65 in the 65 to 70 class interval. Similarly, we will group all the numbers. In this way, we will also get a grouped frequency distribution table here. Let's compare the first table with this table. Do you see any difference between the two? Think. Let us tell. None of the two classes in this table have overlapping lower class limit or an upper class limit. That means that classes are not overlapping. Such classification or distribution of data when the class is non-overlapping. This is called discontinuous frequency distribution. In this way, it is a discontinuous frequency distribution table. If we talk about this table, then there is overlapping of the classes in it. That is, the classes are overlapping. Such a distribution of data is called continuous frequency distribution. This gives us a continuous frequency distribution table. Today we learn grouped frequency distribution. In the next video, we will solve some interesting examples related to them. Today we will see examples related to grouped frequency distribution. Example: the height of children in a class was measured. The frequency distribution table shown below shows the data related to it. Convert the shown table into a continuous grouped frequency distribution table. The table shown below shows the discontinuous frequency distribution because the class intervals here are non-overlapping. That means there are gaps between upper and lower limits of two consecutive class intervals. Suppose the height of a child is 129.5 centimeter, then in which class interval will it be included in the table? Think. Let us tell. Since 129.5, this number is greater than 129, it cannot be included in the class interval 120 to 129. Similarly, 129.5, this number is smaller than 130. So, it cannot be included in the class interval 130 to 139. Thus, this number cannot be included in any class interval. In such a situation, it is necessary for us to convert the discontinuous frequency distribution into a continuous frequency distribution table. So, let's start. To obtain a continuous frequency distribution, we must divide the class intervals. This will make the upper and lower limits of consecutive intervals equal. For this, we will subtract the upper limit of one class from the lower limit of the next class in consecutive order and divide the result by 2. Like we will subtract the upper class limit 129, which falls on 120 to 129 from the lower class limit 130 of the next class, 130 to 139, and divide the result by 2. This will give us the result as 0.5. Now we will subtract 0.5 from the lower limit of each class, such as 120 minus 0.5 is equal to 119.5. Similarly, we will add 0.5 to the upper limit of each class, like 129 plus 0.5 is equal to 129.5. In this way, we will create a new class interval 119.5 to 129.5. Now, you pause the video and similarly, in this way, find all the class intervals. You will get the class intervals as follows. Can you tell whether these class intervals are continuous or discontinuous? These are absolutely continuous class intervals. Now we can organize these groups in this way. Now, this table is a continuous frequency distribution table. Now, can you tell in which class interval 129.5 will be included? Think. Absolutely right. 129.5 is overlapping between the class intervals 119.5 to 129.5 and 129.5 to 139.5. And we include overlapping observations in higher class intervals. So the number 129.5 will be included in the class intervals 129.5 to 139.5. Today, we saw example of a grouped frequency distribution. In the next video, we will see some more examples related to this. Today, we will see some more examples related to grouped frequency distribution. Before looking at any example, let's understand what a class mark is. The midpoint of any class is called the class mark of that class. The midpoint of a class interval, that means the class mark, is obtained by dividing the sum of the lower class limit and the upper class limit by 2. For example, the midpoint of a class interval 10 to 20 is 15. That means the class mark of a class interval 10 to 20 is 15. Similarly, can you tell what will be the class mark of class interval 150 to 190? Think. Absolutely right. Its class mark is 170. Let us now see some examples related to this. Example: if the class mark of a class is 45 and the upper class limit is 65, find the class interval. Here the class mark is 45 and the upper class limit is 65. Let x be the lower class limit. Now we can say that the class mark 45 equal to the sum of lower class limit x and upper class limit 65 divided by 2. By simplifying it, we will get the lower class limit x is equal to 25. In this way, the class interval is 25 to 65. Example: the table shown below represents the midpoint of the class intervals. From this information, make a continuous frequency distribution table. The midpoints of the class intervals are shown in the given table. To make a continuous frequency distribution table, we need to find the class interval. Here, we are not given the lower class limit or upper class limit of any class interval. Can you tell how we would find the class interval in this case? Think. Let us tell. Suppose the midpoint of a class is M and the class size is H. You must remember that the difference in the upper class limit and lower class limit of the class interval is called its class size. Since the midpoint is between the middle of class intervals, so difference between any two consecutive midpoints will have the same difference as the difference between a lower and upper class limit of a class interval. In this way, we will find the class size h by the difference of consecutive midpoints, which is 20 minus 10 is equal to 10. If we reduce this difference to the half of class size, we will find the difference between the midpoint and the lower class limit or the midpoint and the upper class limit. H divided by 2 equal to 10 divided by 2 equal to 5. If we subtract this difference from the midpoint, we will get the lower class limit 10 minus 5 equal to 5. Similarly, if we add this difference in the midpoint, then we get the upper class limit 10 plus 5 equal to 15. In this way, we get the first class interval 5 to 15. In the same way, we can get the lower class limit 15 of another class by subtracting 5 from the midpoint 20 and adding 5 to 20 to get the upper class limit 25 of the second class. So, the second class interval will be 15 to 25. Similarly, we can find all class intervals in this way. Now we can make continuous frequency distribution table in this way from the information given. So today we have seen some interesting examples related to grouped frequency distribution.